In this next tutorial, we look at another one of the visualization tools provided for in Splink. In particular, we're looking at the Splink Comparison Viewer. Comparison Viewer is a much more comprehensive tool. It's normally used to validate the model that you've created and estimated in Splink. It looks at a variety of aspects of the prediction file, from the individual comparisons to looking at comparisons with particular filters in place. Much of the decision-making process around deciding whether the model that you've created is a good one or not can be done using this tool. Creating the tool is a simple task. The main line that you're interested in is this one here, from the visualizations library, the comparison viewer dashboard. We won't worry about these two other commands. That's far beyond the scope of this particular tutorial. As we did with the last tutorial and what we created in previous tutorials to that, we're going to start on the point where we've created or opened the fake 1000 dataset, and we've given it this data frame the name df using these commands here. We also assume that you've created the settings and that you've saved them, and we will open the settings with this command. You will have to input the location where you've saved your settings file. We're going to let linker be this function here, and we're going to assume that you've done the linking process, and it's called df predictions. So df predictions contains all the information from the linking process and the estimation of the model. So we'll now go ahead and we'll use the command that you saw at the beginning of the tutorial. So this command here, and we'll just go ahead and create this comparison tool viewer. And this is the output. So let's go through it from the beginning. Now, this allows you to sort this histogram below by the likelihood of matches. This allows you to change filters so that we will just be looking at comparisons in which there's a null involved, for example, in the first name, or we have exact matches on the first name, or we have particular Gerald-Winkler distances, etc. So you can filter this large amount of data here according to any one of these particular filters we have here. What the filter out comparison vector does is this filter will allow you to choose particular combinations of variables in which there are more than a certain number of comparisons. So if there's only one comparison, then you're going to have all of the comparisons there. But if you just want to look at the more common types of comparison, you would increase this number. That's far too high. So say 5. And Now we're just looking at comparisons where there's more than 5 of any particular combination. We'll go back to 1 now. Now the most important part of this chart to begin with is this table here. And what it does is it goes through all the different combinations of possible comparison types that you can have. So you can have comparisons where you've got a match on first name only and not on surname, not on date of birth. It's very difficult to see, but we'll investigate how you can look at this better in a moment. And where you don't have a match on city and you don't have a match on email. So the least likely matches represented down here, and all the way up here you have things where you have an exact match on the first name, an exact match on the surname, exact match on date of birth, etc., etc. Now, I said previously that you would be able to have a better look at these particular numbers in here. So what you can do is you can focus on a particular aspect of the graph. So if you click and hold and drag, we can have a look at, say, these particular units. So what you can see here is we're looking at the number of comparisons where there was an exact match on first name, an exact match on surname, there was not a match on date of birth, it was all other comparisons, where the city was null, and where there was an exact match on the username of the email. So there were 7 comparisons that had those particular features. Whereas if we say take this number of comparisons, so if we were thinking about comparisons where there were an exact match on first name, an exact match on surname, an exact match on date of birth, with null city and null email, there were 13 comparisons of this type. So this chart allows you to focus in more when you have such a big data set or such a number of matches and types of comparisons as we do here. To zoom back out, you just simply click the button. And we've zoomed that back out again. Now, in this chart, what you can do is hover your mouse over any one of these particular bars and you get statistics for all of the comparisons. So, for example, we hover over here and this gam underscore concat tells you the types of comparison that we're looking at. So we're looking at where the first name was in the comparison table or comparison level 4, the surname was comparison level 4, the date of birth was comparison level 0, the city was comparison level 1, and the email was comparison level -1. And what we can do then is we can click on that particular bar and we will see the records the waterfall chart for the records of that type. And we can have a look at a couple different examples. So this is the waterfall chart for a person called Hugo Kauer, who had these particular comparisons done. So there was an exact match on first name and on surname. There was no match. Oh, sorry, this is the term frequency. There was no match on date of birth. There was a match on city and the final score, and we can look at another example of someone from this group, and this is Oliver Atkinson, who fell into this group as well. We can do this for another one, say one where it's not so likely we will see a match. So what we're looking at here is comparison level 1 for first name, so that's not a match. Comparison level 4 for surname, which is a match. And date of birth, city and email, comparison levels at 0, -1, and -1. So if we click on that bar, we'll see an example record. This is Michael Welds, and here's the details. And from this chart we can see why it's so unlikely that we think that this is a correct match. The first name and the surname do match, but the date of birth doesn't, and the other fields were actually missing. Now you might want to explore, well, what happens if we have an exact match on first name, and suppose we also have an exact match on surname. And let's look at the kind of comparisons that we have for this particular filter here. So we can see that we have match on first name, match on surname, comparison level 0 for date of birth, comparison level 1 for city, which is an exact match, and we do not have a match on email. So you can reduce the data set that you're looking at and look at specific combinations of when you have exact matches or not exact matches. So you can choose, well, what would happen if you were looking at a Jarrell-Winkler distance of greater than 0.92 with an exact match on the first name. These are the different combinations of the variables comparing. And if you looked at, say, this particular example, you can pull up what the final weight would be for a couple of different examples. Archie Scott has a very high final score, and Leon Armstrong also. The last thing that you might want to do is, viewer, we will reset this, so we're looking at any, and now we will just look at So this tells us the number of comparisons. So for example, this was there were lots of comparisons made with this particular combination of comparison levels, whereas lots of these only occur one time. So if we just filter out the ones that occur one time, or maybe even filter out the ones that occur just twice, and now we have something which I guess is much more important in deciding whether your model's doing a good job. And you can go through each one of these and check that does it make sense if, for example, there were 3 comparisons done like this. Does it make sense that this person here should not match? Or does it make sense that that these people here, which have this particular combination of matches, does it make sense that these match or not? So by going through this table from the least matching to the most matching, you can decide if you've got a valid model for making these predictions. One thing that you can do is you can just change here, and that will now give you, instead of what we had before, will give you more detail here instead of just the number 0, 1, -1, etc. That brings us to the end of examining the comparison viewer tool.